right, do you want to? What? I am? All right, we're going to go ahead and get started. If y'all want to make your way back to your seats, mostly for me. Um, all right. Larry, are you good to start with nuclear materials? Oh, I'm so sorry. I was looking at break instead of lunch. I thought we were further down in the day. Earl, you ready for waste management?
Sure. Welcome everybody back from lunch. Glad to have you at the New Ellington Meeting Center. I'm Earl Shepard, the chair of the Waste Management Committee. Members are Virginia Jones, Louis Chavis, Susan Corbett, Marilyn Ennis, Don Gillis, David Hoyle, Daniel Kaminsky, and John McMichael. Committee purpose is up on the screen. Moving along. The Waste Management Committee has no open or pending recommendations and one draft recommendation. And the draft is waste management milestones. Our next Waste Management Committee meeting, I'm sorry, and there is a copy of the recommendation that we'll go over and vote. Our next meeting is August 9th, 6:30 to 8:20 p.m., right back here. Today, we'll be having a presentation, but before I announce Mr. Pete Hill up here, what I'd like to do is introduce Tom Foster. He's the new SRR president and project manager. Thank you, Tom.
All right, well, good afternoon. It's very nice to be here and be able to speak to you all very briefly. I won't take time away from Pete's presentation because he's got the meat of what you all want to hear about. I'm new in post. I've been here just a little over 2 months, and I just wanted to come and introduce myself. I haven't had a chance to speak before this group before, so it's just a bit about introducing myself. I spent the last 5 years working at a place called Sellafield. Some of you might be familiar with it, but it's an installation in northwest England. It does a lot of similar processes that we do at Savannah River site. Biggest difference is it's all compacted into a very small footprint, about 2 square miles, even though it has almost the same number of facilities as we have at Savannah River. So very interesting time, challenging time. I learned a lot, though. Some different ways of doing things, different ways of approaching solving problems. So that was a good, healthy experience for me. Prior to that, I worked at Hanford for a few years on the River Corridor Cleanup Project. So I got some good decommissioning experience out there, and again, some different ways of looking at doing work. So prior to that, I was here at Savannah River site for about 27 years. So this is really a homecoming for me. I worked mostly in the NNSA programs when I was here before, but it's been a real pleasure for me professionally to get back to the site. It's really been good to get back and see the safety culture that's still really vibrant and alive here. The work ethic of the workforce is tremendous. The progress that's being made, the progress that's been made since I was gone. At a personal level, it's really good just to kind of be back home. So I want to thank you all for your time. I know this is taking time out of your busy lives to come and do what you're doing here, but I think it's really important for the community, and I appreciate your contributions. And so without further ado, I'll let Pete get into the meat of what we're here to today. Thank you.
Thank you.
Okay. I think I'll skip that. Oh, yeah. Well, I'll introduce myself while they're pulling the presentation up. As Earl said, my name is Pete Hill. I am the System Planning Manager for SRR Savannah River Remediation. We are the liquid waste contractor at the site. And today I'm going to give a brief discussion on System Plan Rev 20. And I'll start off by giving an overview of the liquid waste system and a brief status of where we are. Then we'll talk about inputs to this plan and how they differ from the previous plan. We'll look at the results and then have a very brief summary. So when we talk about the system plan and the liquid waste system, What we're doing in the system plan is looking at the waste that exists in our waste tanks today and any future waste that we may get from H Canyon, and we model that waste as it is processed either through DWPF or the salt portion, which is about 33 million gallons out of the 36, currently being processed at ARP-MCU, and then eventually through SWPF, and in some of our scenarios through a third unit, which I'll discuss in a slide or two. So today, as I mentioned, we have 36 million gallons of waste in the tanks. About 3 million of that is called sludge. It sits in the bottom of the tanks. We've been processing sludge at DWPF since March of 1996. The figures on the slide are current as of the end of March. Except for tank closures, we added tank 12, which was closed in April, so that's up to 1. But DWPF has processed around 4,000 canisters, which is right around half of what we're projecting it'll have to produce in its mission. The other 33 million gallons of waste is collectively called salt waste. That's divided into two portions. About half of it is salt cake. It's precipitated salt solids that are also in the bottoms of the tanks. If you think of a salt block like you'd have for livestock, it's very hard like that. Then the remaining 17 million gallons of salt waste is dissolved salt solution, which is sitting on top of the salt cake. Before the salt cake can be processed, it has to be dissolved, and the salt, even the liquid salt waste, requires some chemical adjustment so that it can be processed. So that 33 million gallons of salt waste turns into a little over 100 million gallons of feed for the salt processing facilities. ARP, which has been running since 2008, SWPF, which will be coming online here in 2018, and then in the Rev 20 of the plan, the ticker unit, which I'll discuss. The system is designed so that the vast majority of the radioactivity, the 252 million curies that we currently have in the tanks, the vast majority of that ends up vitrified in glass canisters that will be disposed of at a federal repository. Less than 1% will remain in the tanks after they've been cleaned and be grouted as part of the tank closure, and much less than 1%, less than 800,000 curies will be solidified in the grout at Saltstone. So changes to system plans are primarily driven by four things. Either we have advancements in technology and we can deploy that in the plan. We'll also resequence or reprioritize the activities that we desire to pursue. We can get acceleration opportunities. An example there is ARP-MC was originally designed to process at around 4 gallons a minute. We've run it as high as 8.5 gallons a minute, and we're at a steady state now, a little over 6. So that's given us an opportunity to accelerate some of the waste removal. And by far the most common change between system plans and the biggest impact you're going to see going forward are funding profiles that we use to model against. And when we compare Rev 19 that was produced 2 years ago to Rev 20, the system plan, we see that 3 of these different drivers actually come into play. The tank closure cesium removal, which is a vendor-purchased unit that removes cesium. It's located at or near a waste tank to help accelerate closure of some of the older style type 1 and 2 tanks. That technology has matured to the point where we've included it in Rev 20, the system plan. For this plan, DOE asked us to look at, as the second priority for waste removal, the first priority has been consistently with previous plans, Rev 19 and 20 included, to remove the waste from the H area type 1 and 2 tanks that are located at or near the water table. So that's tanks 9 through 16. 16 and 12 have already been closed, so 6 of those tanks are remaining. That's the first priority. In previous plans, the second priority then would become the other type 1, 2, and other type 1 and 4 tanks, 8 of those. in F area and 4 in H area. For this plan, they asked us to, after the type 1 and 2 tanks in H area, have the waste removed to target our efforts on getting the waste out of F tank farm so that tank farm could be isolated, therefore significantly reducing the cost of infrastructure maintenance for the whole liquid waste program. And as I mentioned, this plan also has a significant funding improvement over the previous plan. Some other inputs that drive the outcomes. SWPF is expected to start up in December of 2018. We expect to continue to receive waste from H Canyon through 2025, and then they'll flush their facility out in 2026. We assume that glass waste storage building number 1 will be completely double stacked with 2 canisters for each storage location. That increases our storage capacity by over 2,200 cans, and I'll explain in a couple subsequent slides why that's important. And as I mentioned a couple times, the tank closure, cesium removal, or ticker will be demonstrated on tank 10. The ticker unit is a unit that's procured from a vendor that we will supply dissolved salt solution out of tank 10. The unit will remove cesium, with the decontaminated stream being returned to tank 11, where it is then transferred to saltstone for incorporation into solidified grout. The unit, which will be ion exchange, will produce a loaded resin column. Our objective is to find an off-site disposal location for that column. The column is designed, however, if off-site shipment cannot be arranged, that the resin can be introduced into the DWPF feed stream and vitrified, and ultimately ending up in one of the canisters. For this plan, the base case of Rev 20, we are assuming that we just do a demonstration of the viability of the technology on tank 10. If you look at Rev 19, which was issued 2 years ago, by far the most significant outcome from that modeling effort was that the constrained funding profile we were given to model against resulted in SWPF not being able to operate at its rated capacity because the rest of the liquid waste system couldn't support it. And there's several things there. We could not afford to construct SDUs fast enough so that both ARP, MCU, and SWPF could run at rated capacities. By not running ARP MCU at the rated capacity, that limited our ability to feed SWPF when it started. We also are required to make some modifications to DWPF and saltstone so that their capacity can be increased higher than it is today to support SWPF at higher throughputs, over 7 million gallons per year. And we also could not afford to begin construction on the 3rd glass waste storage building, which in the Rev 19 modeling was required to be in service by 2019. So at around $100 million, there was a significant investment required in FY 16, 17, 18 to have that new building built, and that also would not fit within the funding profile. So as a result, Rev 19's cumulative salt process through SWPF was about 18 million gallons below what the facility would be rated to do. And that, at a top end of 9 million gallons per year, adds 2 years to the liquid waste life cycle on the back end, but it also delayed removal of waste from the old style and salt tanks in the near term. With a significantly improved funding profile for Rev 20, all of those things I stated before have been relieved. And with the inclusion of the double stacking of glass waste storage building number 1, which alleviated the need for heavy investment on the front end for a 3rd glass waste storage building, those revisions to the inputs allow us to fully support SWPF at the rated capacity when it operates, giving us a significant increase in cumulative salt processing. So looking at the timeline, what we get relative to waste removals and tank closures from SWPF running at full capacity. we can see that all of the bulk waste is removed from F area type 1 tanks, and primarily that's tanks 1, 2, 3, 4, 7, and 8 by 2023. We then, those tanks enter a heel removal and isolation and closure, finally occurring in FY32. We then, as I mentioned, target the waste that is in the type 3 tanks in F area before retrieving the final waste out of the type 4 tanks in H, which are old style tanks. So by 2029, the bulk of the waste is out of F area with those tanks being closed early in the 2030s. The final waste comes out of type 4 old style tanks in H area in 2030 with the type 3 tanks a couple of years later, final closure in 2037. One of the things you'll notice looking at this particular timeline is that with SWPF operating at the rated capacity, a significant portion of the funding that is available is used to construct new SDUs and to do bulk waste removal from salt tanks so that SWPF can be fed, and therefore a lower priority is placed on final isolation and grouting of the old style tanks. Some other dates of interest in Rev 20, the base case. The need date for SDU 6 is January of 2018. I know you've been briefed several times on the status of that disposal unit, so one of the things you'd like to keep the pulse of is when SDU 6 is going to be available. The current schedule has it available early in calendar year 2017, so there's still significant margin over the need date for SDU 6. Another thing the CAB should keep an eye on is construction of SDU 7. It's needed in November 2020, and I know that seems like it's a long way out in the future, but it takes about 4 years from when groundbreaking begins till the unit is ready to have waste disposed, which means we need to start activities on SDU 7 in 2017. Being a significant investment for DOE, that's one of the things that requires specific approval, congressional approval to begin. And so as the FY17 budget process unfolds, we need to keep track of our ability to start construction on SDU 7. With the complete double stacking of Building 1, the third glass waste storage building or subsequent canister storage is not required till 2029. And next generation solvent is deployed at SWPF at the end of the third year of operation. And that's an important date because the next generation solvent allows us to operate SWPF above the maximum 7.2 million gallons with the current solvent or the baseline solvent up to as high as 9 million gallons per year. So we get additional throughput, and it also has a higher cesium removal efficiency. In addition to that base case that I've just described, DOE asks us to look at alternative cases. For Rev 20, we had two. One was look at, with all other inputs the same, how would the outcome appear if SWPF started up on its late startup date of January 2021. And as you'd expect, there's pretty much, in the timeline I showed you earlier, a 2-year delay in all of those end dates. The third case is a little more interesting. For this case, DOE asked us, let's assume that the ticker demonstration on tank 10 is very successful. Let's process some more of the H area old style waste through that ticker that we're procuring. So we process also tanks 9 and 14 in this modeled case. And we also procure a second ticker unit and deploy it in F-tank farm and use it to process the waste out of tanks 3, 2, and 1. We also continue to keep the acceleration focus on F-tank farm, and for this case, we deployed that next generation solvent 1 year earlier, so that allows us to go to 9 million gallons a year sooner. A comparison of the outputs then of the base case, case 1, and case 3, you'll see that the F area old style tanks are grouted sooner. And as I described before, most of this duration between when the bulk waste removal is complete and the tanks are finally grouted was due to availability of funding. With an improved funding profile for case 3, that gap goes away. The addition of the second ticker unit accounts for this acceleration in removing the waste from the type 3 tanks, and you also get then a subsequent acceleration in closure of all the tanks in F area. In this case, it's in 2028, we're able to cut the inter-area transfer line so that all the waste is out of F area. The surveillance and maintenance cost drop significantly at that point in time. You'll also see a slight acceleration then in removal of the waste from the HRL style tanks, and then essentially an acceleration in the end of the life cycle as well. So just in summary, the big soundbite for Rev 20 is that the significantly improved funding profile over Rev 19 from 2 years ago allows us to fully support SWPF at the rated capacity. Supporting SWPF at the rated capacity is by far the most important attribute of shortening the life cycle of the liquid waste program. Some additional funding could allow us to deploy a second ticker unit and it accelerates some of the bulk waste removal. And you will also obtain a little bit of life cycle acceleration. So with that, any questions? I kind of talked fast there, I'm sorry.
Pete, is it possible that you could go back over
Yes.
the ticker unit?
Okay.
I'd like to kind of know, is that a physical or chemical or electric?
Okay.
What kind of unit is that?
So,
and exactly what?
yeah, it's ion exchange. So you process salt waste through a column that has a resin loaded inside it. That resin has an affinity for cesium. So when the salt waste containing cesium passes through the column, the cesium molecules will adhere to the resin, and therefore the salt waste that comes out of the unit has been decontaminated. So it's a chemical process. Obviously, it will require, it has pumps, so it'll have electrical hookups
Right.
and that kind of thing, but the cesium extraction is a chemical process.
Well, I was letting Earl do it because I was being nice, but I'll go on. Susan?
Susan Corbett, CAB. What percentage of the cesium can you remove through this ion exchange process? Is there a percentage?
Yeah, it's interesting. Ion exchange, when the resin is clean, it has a very high cesium removal efficiency. So you can actually control the decontamination factor by how long you leave the column in service. Our objective would be to use the column to achieve an equivalent decontamination factor as SWPF, which is in tens of thousands.
Okay.
There are several options. The most likely would be waste control specialists in Texas at their greater than Class C landfill.
I was going to ask you,
when
this is
permitted.
greater than Class C waste then, isn't it?
It will be, yes. Now, a nice feature of ion exchange, again, is you control the loading, and we could, when deployed, load them to less than Class C, but the plan is a greater than Class C waste form.
Okay, and I think that's it for now. Thank you. Thank you.
Dawn?
Dawn Gillis, CAB. I just want to clarify on the salt waste. Did you say that it's expected to be about 800,000 curies total when everything is said and done in salt waste?
In saltstone?
Saltstone, yeah.
Yeah,
Saltstone.
the target that we develop our plan to is to maintain less than 800,000 curies. We're actually modeling that the number will be closer to 600,000, but our max target is 800,000.
Okay, thank you. Yeah, I saw a source somewhere that said it was going to be 3 to 5 million curies left in saltstone on the site, so I wanted to make sure that was
Yeah.
that I'd understood what you were saying.
Yeah, the basis for that is the original waste determination that was approved by the Secretary of Energy and evaluated by the NRC included a range of 3 to 5 million. We are significantly below that.
Okay, thank you.
Shelley?
Thank you for your presentation. So there was a question earlier this morning about how much money liquid waste needs. And so I'm curious, what is your funding profile for this Rev 20 and your Case 3?
Okay, so for Rev 20, FY16 that we're currently in, the funding profile that we used to model was around 445 million. We're currently funded above that. The needs for FY17 were in the 475 million range. The president's budget request exceeded that with the not having a budget and the House and Senate marks. Those are actually below the 475. So they're in the ballpark. President's budget is above it. FY18 goes to a larger number, around 500 million. And I don't recall the ones that are after. The plan is published and they contain those figures. The Case 3, it's nominally over a 10-year period, an average of 50 million additional dollars per year. It's not flat. There are some years that are 70 million, others that are 30. But over a 10-year period, it's about 500 million more than Case 1.
Okay. And is that money that goes to the contractor rather than what you would see in the president's budget? When you're talking
Yeah,
about
the numbers I'm talking, are the numbers direct to the liquid waste contractor. There are dollars for pension and site services that are in the president's budget above that.
Okay. So, and just to translate to the earlier question, so it sounds like for Case 3, which is the most aggressive case for treatment, you would need, on average, of 550 million per year of money that goes to the contractor. And so when you look at the president's budget request, there's normally a significant amount above that because it's the whole liquid waste budget that the site needs. They give part of it to the contractor, part of it to pension payments and various things. So, so just keep in mind that 550 number would need some extra in the president's budget to account for this.
So no, it was, we were publishing this plan when the 3H evaporator, we first were discovering the pot leak. So no is the direct answer. Immediately following the failure, we ran an analysis against the base case of the plan with minor adjustments. We're able to accommodate a 3-year outage or a period of 3 years without having the 3H evaporator for either repair or replacement. It did require some resequencing of sludge batches and some resequencing of the salt waste, but there was no impact to the life cycle dates that I showed.
No impact.
No impact. We got very, I'll say lucky, it's probably not a good word to use, but the evaporator failed at the right time. We had just completed washing sludge batch 9. The next tank that is in sequence, tank 22 sludge, contains material that is essentially pre-washed, so that could be staged as well. So we could have 3 years worth of sludge staged for DWPF before we need to begin washing the next batch. And we had just completed salt removal out of the 3.
Ones are double walled, some of them have leaked, some of them have. What criteria are you using to decide which ones to empty first?
Okay, so we work with DOE on that prioritization. And for this plan, the highest priority were the, I'll call them single shell, the tanks with only a secondary pan in H area, the type 1 and 2 tanks that are located at or near the water table. So they have a complete, obviously, primary tank, and they're sitting in a 5-foot secondary pan.
Right.
The second priority were similar design tanks, type 1 tanks in F area. They're second in priority because they're not located in the water table. They also have a 5-foot secondary pan. So at this point, after those tanks have the waste retrieved, we have the option of F area tanks that have full secondary containment, the double shell tanks, or there are 4 tanks in H tank farm that are called type 4 tanks. They are also single shell tanks that have no history of leakage, and they're located significantly above the water table, so they're very sound. In previous plans, we had prioritized those type 4 tanks ahead of the F-area double shell tanks. For this plan, DOE asked us to look at accelerating the F-area type 3 tanks to determine what benefit we could get in infrastructure reduction and therefore get acceleration over the remainder of the plan.
Okay.
And then last would be the H-area type 3 tanks.
Thank you.
David, did you have a follow-up question? No. Shelley, did you have something? else? You're fine. Just making sure. Oh, Louis?
Yes, sir.
Mr. Hill, great presentation.
Thank you.
I want you to take us to fiscal year 42,
Okay.
25, 26 years from now. From now up through fiscal year 42, we're looking at allocations of about half a billion per year,
That's correct.
approximately.
Yes, sir.
Under current value,
Mhm.
26 years from now, that $500 million would be maybe 800, whatever. What do you see doing in regards to tank cleanup?
Some portion of the liquid waste facilities completely D&D'd and undergoing that final environmental remediation, and the remainder going the D&D process.
Thank you.
Thank you. Are there any other questions from around the table? Great. Earl, do you have anything else on it?
Great job, Pete. Thank
Thank you, Earl.
Thank you.
Thank you.
Tab that the September tour is all in liquid waste, so this is the stuff you're going to be talking about. So remember
Perfect.
that.
Good promo for the September tour.
What was the date again? I'm sorry.
September 14th.
Okay, we're now at the point where we're gonna vote on the recommendation, waste management milestones.
Right. Is there any discussion on this recommendation from yesterday on waste management milestones? All right, hearing none, do we have a motion to approve?
I make the motion that we approve.
Okay, do we have a second?
I'll second.
Second. All right, if you are in favor of this motion to carry, please signify by raising your right arm, hand, something.
And
Do you have
that's a
anything
wrap
else for me?
for Waste Management Committee. Until the next time, thank you.
That sounds perfect. Thank you. We are up to public comments. I don't know if anyone has signed up at this point to speak, but if not, if anyone would like to come up. Yeah, you can speak. I mean, don't push each other down for it, but.
My name is Marilyn Parson. I'm from Bluffton, South Carolina. At the end of Brian Hennessy's presentation this morning, he talked about the D area ash basin removal action that was out for public comment. Actually, it went out for public comment on June 15th and closed on July 14th. And I would like to share I submitted official comments, and I would like to summarize my comments today. Basically, the comments are on removal site evaluation report, engineering evaluation, cost analysis for the D area, ash base against which the other alternatives are evaluated. Then the second alternative actually involves moving the ash well, they have to dewater and a bunch of other stuff, but basically end up moving the ash into an area that occupies about half of that area, so about 19 acres. They're also taking some contaminated soil from a coal runoff pile. There's also some ash that is near the Area D ash landfill, that there was some ash, the exterior to that, and they would also put that into, so it would occupy an area about half of the original basin with the inlets. And then they're going to engineer a cover on it, and it includes a geosynthetic cover system. Then the third alternative that is discussed is taking the ash and depositing it in a landfill that is a lined landfill, and there are special Resource Conservation Recovery Act landfills that are that this could go into. I believe that if the ash basin can be cleaned up, it should be. Instead, the department has chosen to leave the consolidated ash in the D area, covering it up and putting land use controls around it. There is no long-term or permanent solution, as the cover system that is described will only last about 30 years, leaving the waste to be handled by the next generation of engineers to deal with. It is time that the department dedicates to a strategy of cleaning up the site, not delaying cleanup by covering up or putting a fence around it. Thus, I favor alternative 3, ash excavation and off-site disposal. I recognize that this is the most expensive of the 3 alternatives that are being proposed, but if this alternative were selected, in 3 years' time, 40 acres of land at the Savannah River site would be cleaned up for good with an unrestricted land use designation. This should be the Department of Energy's goal for the 488-1D ash basin. Further, I am disappointed that the department did not offer a 4th alternative, which I have called Alternative 4, beneficial reuse and off-site SRS disposal. In 2014, the United States Environmental Protection Agency finalized the final rule on coal combustion residuals generated by electric facilities world recently in the last couple of years. This proper removal and disposition of this coal ash is very important. 450,000 comments. 450,000 comments were received by EP on this rulemaking. That's pretty incredible. Now, also as part, basically the intent of this rule is to protect human health and the environment by requiring liners in landfills where ash is deposited, and by restricting the location of landfills and surface impoundments. Now, in addition, the rule supports the beneficial reuse of coal ash. The beneficial reuse of coal ash is not new. It has long been recognized that coal ash can be processed so that fly ash from it can be used in concrete and wallboard. A new process called the STAR process has been developed by a South Carolina company, the CIFA Group. The STAR process is capable of thermally treating pond ash with the end result of 100% inorganic fly ash that can be used in concrete and other products that use fly ash. The STAR process does not generate any solid waste and generates hot water as a byproduct, which can be used by the utility. Coal ash at the Savannah River site that need to be disposed of before the cleanup of the site is completed. In addition, the Savannah River site uses fly ash, the end product of this STAR process, in the grout to fill the underground storage tanks when they're cleaned out, for grout when the low-level waste is processed in the salt processing facility, and for other construction projects where concrete is used. The representative of the CIFA Group that I spoke with said that the Savannah River site was one of their fly ash customers. I just wanted to, just on a personal note, I do not have a naive understanding of beneficial reuse. One of my former positions was a pollution prevention specialist at the Manufacturing Technology Center in Whitfield, Virginia. And my job was to help manufacturers reuse and recycle their waste products. That being said, I believe that my proposed alternative for beneficial use and off-site SRS disposal would be a viable option for this ash basin. The Savannah River site is fortunate to have very smart engineers who on a daily basis solve very difficult problems. In fact, shouldn't it be the Department of Energy leading the way to show the nation how coal ash can be beneficially reused? It makes perfect sense. After all, coal ash is a waste product produced when energy is created. In my fourth alternative that I had proposed, I also included an off-site SRS disposal in my alternative 4 because I felt like it was probably impossible that every cubic yard of ash in these basins could actually be put through the STAR process. Site. Thank you.
Thank you.
I'm Suzanne Rhodes of the League of Women Voters. Last week there was a symposium in Aiken on issues. Anyway, I thought it went well. A local reporter who's really new on these very complicated issues wrote it up. I thought he was a little cavalier, to say the least, about the tenure of the meeting, the validity of the information that was shared, and also he insisted that there's no plan to send spent fuel to SRS, and there is. In fact, we've got a couple of posters out here, both from Canada, commercial waste from Canada and from Germany. You know who they are. We are trying now to get our own comment column in the Aiken paper, Aiken Standard, and I hope it's published. I've made a couple tries today, and I'll do one on the way out and some phone calls. But I think it really is important that you all know what it may not all happen, but there aren't a lot of places that want nuclear waste.
Which is great. I think our break was actually set for 3:15, and Mr. Gunter is not here yet to do the K area overview update. Oh, is he really? Does he need a moment? Okay. Larry, do you want to go ahead and maybe do your committee update portion and maybe vote on the draft recommendation on improving H Canyon throughput?
Sure.
Okay. Well, it looks like a mass exodus, so I don't know.
I'm Larry Powell with the purpose. If we can go on with that. We have one open recommendation, number 334, Nuclear Materials Operations Review. We have two draft proposals that we're going to vote on today. Our next Nuclear Materials Committee meeting is going to be Tuesday, August 9th at 4:30 p.m. here in New Ellington. And today's meeting, the overview, K area overview update presented by Al Gunter. So, Al, are you ready? No. Okay.
Okay. Are you good on moving forward with the H Canyon recommendation? Or, no, here he is.
Moving right on through.
Tour, so anyway. Okay, what happened to the, oh. All right, I'll be giving you an overview of K area, where we stand today, and kind of an update. Again, the purpose, provide information on where we are on the K area plutonium storage and how it fulfills the Nuclear Materials Program's work plan. Acronyms I will not go over. I will try to speak each one out. All right, excuse me. PU stabilization and packaging, kind of a quick overview. Supposedly in interim storage, ended up in long-term storage, and so we had some issues there. So in 1994, the department issued DOE Standard 3013. What it requires is the oxide material to be stabilized at 950 degrees for 2 hours. It's got 2 welded nested stainless steel containers, and usually it has a third one, which is a convenience can. And then we have a surveillance program to ensure that we don't have any degradation during storage. Excuse me. When the standard was put together, there were 2 issues that we were worried about. One was pressurization, and the other was corrosion. And that's what the surveillance program was monitoring to see, were we seeing any pressurization or corrosion. The department began packaging in late 2001. Rocky Flats Environmental Technology site out at Denver, Colorado was the first site that started up. Hanford, Los Alamos, Livermore, and Savannah River came kind of almost in that order, although I think Livermore was before Los Alamos.
This is K area material storage in 2000. 1998, the department made a decision to convert the K reactor over to a plutonium storage facility. Roughly in 2 years, we converted it from a reactor, standby reactor, into a plutonium storage facility. That's what it looks like now. That was in 2009, 2012. It's just a little bit fuller. But this is what it would look like inside. K area is basically a warehouse. It stores 35-gallon drums. They're palletized 4 to a pallet, and we can stack them 3 high. What is the storage configuration we have? I talked a little bit about the 3013. When it's loaded with plutonium, it weighs approximately 30 pounds. It's about 10 inches tall, 5 inches in diameter. Those are placed inside of 9975. This is a cutaway of the 9975. The 3013 sits there. It's inside of a primary containment vessel. It's inside a secondary containment vessel. It's got a 1/2 inch of lead around it. It then has either cane or wood fiber board in there for thermal and shock protection. This is a Type B shipping containers. It's been tested, dropped from 30 feet, put through a fire testing and all of that. Go back. Kind of give you an idea of the 3013. You've got the outer container, which can be certified as a safety class component. You've got an inner welded container, and then like I said, normally you have a convenience can. The whole idea behind the convenience can is when you're welding this, you do not want loose plutonium oxide around there. You'll end up with plutonium in the weld. Where are we on the surveillance program? We had an approved program plan in 2003, as approved by Assistant Secretary Roberson, Jesse Roberson at the time. We have a working group that is made up of personnel from Savannah River, Hanford, Los Alamos, and Livermore. They are some of the experts within the department. What we look at there is they direct what we have called the shelf life program. Los Alamos holds a sample of every type of material that is stored in K area today. We have both small scale, large scale samples. They take thermal tests on them. They determine the gas atmosphere around the material and all of that. We also are doing some corrosion tests at both Los Alamos and Savannah River National Laboratory. What we're trying to do is force the container to have a stress corrosion crack, so we will know how that reacts and what causes it, because we see that as the only credible scenario that could cause a failure of the container, but there it would not be a catastrophic, it would just be a crack. And then we have 3013 containers that we do examinations. We pull them out of K area and we actually cut the cans open. We take samples of the material, we take samples of the gas, we actually take the top of the container up to SRNL, and we bend it at the weld joint to see if we see any cracking and all of that. And that is all based on we have a randomly generated group, and then we have ones that the MIS people to select. Usually they're the highest chlorides and the highest moisture content. And again, I've talked about the shelf life program. We have 1/50th scale. We have 45 positions. We have large scale 9 positions. And we also have some that are using surrogate material because we are concerned with the chlorides and the corrosion. We've been doing both NDE and what we call DE, or destructive and non-destructive. We are no longer doing non-destructive. We did over 40 containers a year for about 8 years, and that fulfilled the randomly generated number that we needed to do to have a 99% assurance that the material stored in the facility would not have an issue. We started doing NDE in 2005. Began doing the destructive examinations 2007. The reason for the gap in there is we wanted the material to be in the containers in a minimum of 5 years, because we felt if you did it earlier than that, you really wouldn't see any corrosion. So we waited 5 years to start the destructive examinations. What we look for is gas composition and pressure. Again, we look at the metallurgical. We look at the physical and chemical analysis of the material. We started in 2007 doing 18 a year. We did that for a number of years. Based on the results we're seeing, we are now down to doing 6 a year. And these include both random and selected ones. Right now, we will see doing surveillances as long as we store material in K area. We do not see a reason that we would discontinue the DE unless we're dispositioning it all. But if it's going to be in long-term storage, our assessment is we need to continue to do surveillance. This is a kind of a picture, looks like some kind of sci-fi thing. But this is the small-scale samples at Los Alamos. Again, there's 45 of them. You can see they're hooked up with instrumentation for pressurization, gas analysis, and all that. This is a picture of the full-scale testing they have. There's one of the 3013s that's instrumented in the storage, and we have room for 7 there. This is a picture of a can that we cut open here at Savannah River where we did the destructive examinations to look at the metallurgical property or condition of the container. This is a picture of it, one of the convenience cans that we did destructive with the plutonium powder in it. Again, that's the powder dumped out. You really can't see it very much, but that's what it looks like. All right, what have we seen so far? We designed the container with for a design pressure of 699 psi. We've seen less than 10 psi in the containers. So clearly, when we were concerned with pressurization, when we generated the standard, that was not a real concern, although we thought it would be because the system. We aren't seeing any flammable gas mixtures in the can itself. We do have hydrogen in the can, but there's no oxygen present, so there is not a flammability issue inside the cans. We have seen some corrosion, and that's one thing with the standard that when we originally started it, we did not think we would see any moisture because we were drying the material to less than 0.5% moisture. However, we are seeing it. Usually it's in the gas space or right at the oxide atmosphere space. We think it's from the moisture generating hydrochloric acid in the atmosphere. It's kind of hard to tell because when we pull the gas samples, if there is any hydrochloric acid, it plates out on the stainless steel line. So even when we pull the gas samples, we really can't tell that if there's any hydrochloric acid. But we're seeing most of it, it's all inside the inner, it's inside the inner can. We've seen none on the outer 3013 can, which are safety class barrier. We've not identified any condition that would challenge the 50-year storage. Right now, even on the inner cans, we see them lasting 50 years. So that's before you even get to the outer can, then you've got the outer can itself. We will continue to do destructive examinations, and we'll have the shelf life program going on at Los Alamos, like it said, during storage. Kind of in summary, we don't see anything that challenges the safety boundary of the material stored in K area. Are there any questions?
Susan?
Very nice presentation, thank you. I just have a few questions because I'm always trying to learn things here. So when you say that you driving off the moisture?
Organics, moistures, anything that would cause a pressurization in the can and cause a potential corrosion in the can. So that's why we're baking it at 950 degrees. And that 950 degrees is not in a 950 degree oven. That is actually what the center of the cake or the bed of the oxide, it gets to 950 degrees and you have to hold it for 2 hours.
Okay, and that basically does what you just said, drives all that out. So I wanted to talk about whether you can see these if they start to leak. How would you know? And you did explain a little bit about that later on here. You said there was a testing where they were dropped and all that. Is it that simulated, or is it if the building caught fire?
These have been put through a fire test also out at Sandia National Laboratory, where you put it in a pool of jet fire. You heat it up for 30 minutes at 1,475 degrees, and we've seen that both the O-rings that are sealing this and they're both, neither one of them are losing any containment.
Okay. Now, if there, you said something about if they started to crack on the outside, it still would not get to the material. Where would, if there, all right, where is the
Okay.
corrosion? Where was
All right.
corrosion likely to be a problem?
Corrosion
It's
is
in the
being-
inner one, okay.
Corrosion is being seen on the inside of this can. Usually the oxide runs somewhere around that level because there's a gap. So right up in that gas region is where we see it on this inner can.
How
No,
can
what
you
we
tell?
do is in the surveillance, when we do our puncturing of the can to take gas samples, we puncture the outer can, we pull a sample of the gas between those two containers. Then after we pull that sample, we go and evacuate it back to a vacuum. We puncture all the way into that container so you can compare the two atmospheres to each other. So you have an analysis of what's in this can. You know that there should be only, there's a 0.5% of helium in that can. And so we're not seeing anything in the space between these two. We know that this can has not leaked. And this is a welded container.
But can the whole configuration be repackaged if
Yes.
if something, okay, it can
Yes.
be repackaged, okay. Let me see here, there was one other. Now, is these containers are considered suitable for transportation too?
This container here, yes, this is
The
what we call a type B,
9975?
a 9975 type B package.
Okay,
Back on the road for shipment, you'd have to open them up, take the 3013 out. You've got to put new O-rings, do a leak check that's required in the SARP, which is a safety analysis for packaging, to demonstrate that they are leak tight all over again. You've got to do that annually if you're shipping on the road. Some of these containers have been sitting in K area since 2002. So we know they're not legal for road, although during part of the surveillance program, we do a surveillance on this can too, this container. And we've been doing tests on the O-rings to see if they're losing their compression, see if they're losing their elasticity. And what we have determined is this, so far, right now, we can.
that can be handled, this container can be handled by anyone? Is there gamma radiation coming off of it? Can it be picked up and handled?
Yes, we
So
handle them every day.
a terrorist could
Yes,
ostensibly take it, steal it.
our operators
and-
handle them every day.
Okay,
I mean, in fact, I was just in the facility today walking right beside the drum, so yes,
okay.
because I was
So-
on a tour with some guys.
All right, thank you very much, very
Okay.
informative.
Thank you. Are there any other questions from around the table? Pat?
No, no.
Pat McGuire with DOE, no question, but Jack Craig mentioned this morning about the down blending program.
Okay.
So can you expand a little bit about that?
Yeah.
What the status of that is?
Okay. From a status standpoint, let me explain. We're going to begin down blending in K area. We did it in 2012 in HB line. However, because of some of the budget issues and also the fact that we were trying to get the facility started up, we suspended that operation in 2012. When we look at starting to down blend, I mentioned we've gone from 18 destructive examinations to 6. We can complete the 6 destructive examinations in about 4 months. So that leaves us 8 months of time in K area with qualified, cleared personnel that we can do some other work. So what we are doing is we have revised the documented safety analysis for the facility. We have approved that. The facility is in the process right now of revising and updating their procedures to incorporate the requirements. And in August, I have to think of what month, August, the contractor will be forming a readiness assessment that would allow us to initiate down blending in the K area glove box where we do destructive examinations. Again, we have a qualified workforce. It takes them about 4 to 5 months to do the destructive examination. That leaves 7 to 8 months to do something else. So what we figured is we would go ahead and down blend material. We will store it, awaiting whip opening and us getting into the queue. But it will allow us to prepare material to get it outside of the state of South Carolina, to disposition it outside the state. Right now, when we start up, we'll start up on a 1 shift, 4 day per week basis. We anticipate that we can downblend about 150 kilograms a year. It's not, it's not a huge amount, but it is making progress. If we can go to 4 shifts, 7 days a week operation, we can get up to around 400 to 500 kilograms a year. Again, we'll prepare the material, we'll get it certified, and then once WIP opens up, we'll ship it to WIP. Downblending is a very simple operation. Basically, they take plutonium oxide, you have an adulterant, we have a pharmaceutical mixture that you turn by hand. You put the two in there together, you downblend the plutonium to less than 10%, you mix it up in a can, the can is then put into what we call a criticality container overpack that can be shipped to WIP and TruePack 2. And that's as simple as the program is. It's taking plutonium oxide. We like to kind of make the joke, we're using the KISS glove box, which was K interim surveillance. We like to keep it simple. And literally inside that glove box, I have a mortar pedestal. I have an industrial coffee grinder. I have a kind of a hammer almost that I can break chunks up with. So, we kind of joke that we got the kitchen sink in the glove box. The whole idea is we want to keep it simple. We don't want to make it complicated. The simpler it is, the easier it is to do the downblending. So what we do is we introduce a can that already has the adulterant, put about 150 grams of plutonium in that can, pharmaceutical mixture, literally 10 turns of a crank, mixes it. It's now ready. We bag it out, put it into a container, and it's ready to go, be certified, and once certified, shipped to WIP.
Thank you. Louis, you have something?
All right.
I just want to add on to what Ellen is saying here. This is the non-moxable plutonium that will be downblending starting in September. It's 6 metric tons that we've been approved to do. The other point I would like to make is that when we talk about transporting this container with plutonium in it, there are guards and guards with it. It's not just put in a truck and shipped over the open road.
Thank you. Louis, did you have something?
Just a quick question. Great presentation. Louis Walters, CAB. With the advent of new plastics and new materials that are being developed, is there anything that you see or conceive of that could do this job better going into the future? Are we going to be looking at, because you mentioned 50 years and that's still only a portion of the life of the materials that's contained. Do you see anything, any optimism at all? Because I'm looking at your face and it doesn't look optimistic.
I don't plan on storing it for 50 years. I plan on dispositioning it before 50 years. I plan on at least the non-moxable, like Jim said. I have approval under the process. We've had agreement with WIP once it reopens and we get into the queue, the priority system. We plan on down. I don't plan on having that material literally. Supposedly for a couple of days, it ended up there a couple of years. Some of the operators went to move it. When they moved it, it literally broke open and they've got an uptake. So the standard actually prohibits plutonium to be in direct contact with plastic. So do I see anything? I guess if you wanted to look, you might come up with some exotic metals. But normally stainless steel, what we're seeing is stainless steel is providing added protection. I don't want to say there'll never be anything because, of course, everything changes. But today, we don't see anything that would cause us to change over from where we are.
Thank you. Are there any other questions? Oh, I just
The whole side opened up.
Alrighty then. Susan?
Nope, not me. I'm done. Sorry.
Okay, David? Not going to turn my back on you people.
David Hall, CAB. Alan, you mentioned that the non-moxable fuel, when it's downblended, you've got agreements with WIP to accept that material at some point. Does that mean that all of the regulatory approvals have been received for receipt of that material at WIP?
The container is licensed by NRC that we'll be utilizing, which is one of the first things you've got to do. The performance assessment at WIP is been completed, it's being re-looked at, just to validate again. My understanding, the permits have been done. The only thing that I know right now that is not done is in their, and I don't know whether it's in their DSA or whether it's in their authorization agreement, which is kind of their DOE license on how they operate, kind of like an NRC license. It is not in the AA that I know that. So once WIP, because they didn't want to cloud it. They're trying to get started to back up on, I'll call it normal, true waste. I don't know what else to call it, the duty. They didn't want to get into changing anything at this point, right now. They would rather start up where they are, then they'll make the change. So I think it's in their DSA, it's just not in the authorization agreement. But as far as I know, as far as the regulatory goes, everything is set up at WIP to handle this material.
Let's see. And New Mexico has no problem with that? EPA has no problem with that?
I can't answer that, David. I'm sorry. I haven't talked to either one, so I couldn't say. But as far as I know, it's in the permit. So I'm making the assumption. And we all know what happens when you make assumptions. I'm making the assumption that if it's in the permit, it's okay with New Mexico. But we're working with WIP personnel, all the time on this. We know that it's not going to be shipped next week. I won't even have down blended enough. If I'm taking a guess, we're out in 2021 overpack container. But again, I'm not going to ship that material, for several years. So we've got time to work through the whole process. But my understanding is it's all been worked through. But that's my understanding. So please don't take that as a yes on everything.
I understand. And how does this material stand in the Savannah River site queue for going to WIP in relation to the remaining 500 or so cubic meters of, as you call it, normal transuranic waste? Is it ahead or behind?
I think it's my guess, and this is Alan, I'm guessing, I think it's behind because we were planning to get the legacy waste out of here. I'm looking kind of at Terry or Jim.
Let me just say this, Terry Spears with the department, that the Transuranic Waste Corporate Board, which is an entity within EM, is the ones who manage the planning for disposition of waste and WIP, including the scheduling of that waste, and that's sort of a matter that's under discussion at the corporate board now. So anything we say at this point would be pure speculation. So we'll just be patient, and I will tell you that they are working on that, anticipating the restart of WIP.
Thank you.
Thank you. And then I think we've got Dawn for our last question.
Dawn Gillis, Cab. Alan, you said that if you were to put in 4 lines into K area to get the stuff ready, you could do maybe up to 400 to 500 grams? Kilograms. Okay, so that's a half a ton a year.
4 shifts, not lines.
4 shifts, okay. That's your maximum capacity is about half of a ton a year.
Right.
So you got 6 tons that are non-moxable, so you're talking 12 years of processing just to get it in the form. Is that much material able, now this goes to what we just talked about, able to be shipped a year, or just going to have to put that back and wait for the queue?
I can't down blend it as fast as it can be certified and shipped. We can, well, let me clarify that. Depends on which was closer to 30 shipments a week receipt. But basically, what we looking at in the future, again, we want them to get started up, let them get back to normal operating. If they get back to that, then they can ship faster, or receive faster than I can generate. Because again, my generation rate's only a half a ton a year, and they can ship 42 drums goes on a shipment.
So how many drums is a half a ton?
Just got asked that this morning. A half a ton? Oh, you're asking for a half a ton?
Well, the
1,600 drums.
1,600 drums, so how many shipments does that make?
40,
a lot, 30.
42 drums on a shipment.
So it's like
400?
no, a lot more than
40.
that.
I think it's 40. I'd have to, I'm not good on my,
All right,
my math is not that good. Let me pull out my calculator.
So what I'm trying to get at is I want to try to make sure of is that what we're producing, again, depending on priorities and how fast WIP comes up and all this kind of stuff, that we're looking at, I'm guessing here, based on, you say we're not going to be able to ship for 4 years, this type of thing, probably 20 years before we could get all of this stuff, this 6 tons off-site.
Yeah, not quite, yeah.
18, 20 years.
And again, it comes down to priority,
Yeah.
comes down to how much funding I get for operating a facility, comes down to how many shipments WIP's receiving, because again, like I said, last I talked to WIP, they're wanting to get back to their old number. Their number was 30 a week.
Yeah.
And my whole thing, so they can clearly receive faster than I can ship.
Pat McGuire, just want to reiterate, everything Alan's saying is
Guesses,
his speculation.
Thank you, thank you, Don.
And so
Educated guesses.
we don't want to speak for WIP, okay? And when we get that information, we'll communicate it to the board, but we definitely do not want to speculate or anticipate what WIP is doing. They're going to start up on a very safe schedule, whatever that may be, and that has not yet been decided yet. We know the CAB and the rest of the community is very wants to know, but we're just not at a point where we can share all that information. When we are able to share it, we will definitely share it with you.
I'm just trying to get a ballpark of how long. I mean, so it's a minimum of 12 years, because it's going to take 12 years just to process it. So.
All right. Thank you so much. Larry, are you okay with a 10-minute break before we get into the recommendation part? It's coming back at 2:35?
Sure.
Okay. Huh? So I'll go. it back. I'm not banging that gavel. Thank you. Steal cookies. All right, Larry, do you want to start it?
Yeah, thank you, Nina. We've got two recommendations to vote on, and we've got two position papers to vote on. And what I thought might be helpful now, since we typically are voting on one or two things, with four different items here, it might get a little bit confusing. So what I'd like to do is before we vote on each individual one, let the author of that paper give 15 or 20 seconds max to discuss what the paper's about. just to remind everybody, I mean, we've beat all these things to death pretty much. So just as a quick reminder, so you won't get one paper confused with the other paper. So our first one is Dawn Gillis. She has a recommendation about improving H Canyon throughput.
Dawn Gillis, Cab, 15 seconds, you timing me?
Yep.
I am.
This is the one that it's a technical one, and just has the DOE doing some kind of analysis to figure out what's the most effective way to use the canyon to be able to get out of the basin sooner, essentially.
Thank you, Don.
Thank you. Do we have any committee discussion about this recommendation? Any questions or comments from around the table? All right, hearing none, do we have a motion? Motion. Do we have a second? Second. All right, if everyone who's in favor of this, please signify by raising their right hand.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
All right, and noes, please raise your right hand. Okay. And abstentions.
We got one abstention, okay.
All right. Thank you, Dawn.
Okay, our next is a recommendation. Gil Allensworth has submitted a recommendation about German spent nuclear fuel shipped to Savannah River site. Gil, could you take 15 seconds, please?
Gil Allensworth. Way to handle, I want to make sure you don't use proper verbiage, handle the waste and that it comes in at a full cost recovery from Germany.
Thank you, Gil. Do we have any questions or comments from around the table? Susan?
I would just, Susan Corbett, Cab. I would just like to echo the comments of our own Department of Health and Environmental Control. I think that the position of DHEC mirrors the position of a lot of people in the state, that we feel like we have enough waste here to deal with. It's costing a lot of money, and we just don't feel like we should be taking any more, especially what we really don't have to take. And I also remembered that we had quite a few emails that came in, and I also attended the public meeting, which was a very large group of people, and it just seemed that public sentiment was opposed to this, and our own DHEC is saying we shouldn't do it. So I think we should pay attention to those voices.
Thank you, Susan. David, did you have something?
Yeah. David Hoyle, Cab. Yesterday during our discussion, I asked the question